Welcome to question number 32 from the August 2017 Geometry Regents exam. In this question, we're given a triangle with 3 vertices, and I've already gone ahead and plotted them on the coordinate plane here. And it says that points A and B are midpoints of PQ and RQ respectively. We need to use coordinate geometry to prove that AB is parallel to PR and is also half the length of PR. So a couple different things we need to get done. So first of all, since we need to find out where points A and B are, using the midpoint formula. So let's go ahead and get started with that. So the midpoint of the line from P to Q we can find by adding the x coordinates and dividing by 2. So it would be -3 plus -1 divided by 2. And similarly, we'll find the y coordinate by adding the two y coordinates of the points and dividing by 2. So that would be -1 plus 7 over 2. And that becomes, if we calculate that out, you should get -2 and 3. So that's our point A. And so that's going to be right there. Now our midpoint for the line QR. Very same method. We're going to add 3 plus -1, divide by 2 to get our x value. And then, let's see there, 7 plus 3 over 2 to get our y value. And we calculate that out and we'll get 1 and 5 for B. So that's going to be right there. Great. Our next step is going to be to calculate or prove that AB and PR are parallel. And we're going to do that by showing that they have the same slopes. And we can do that visually pretty simply here. This, of course, our slope is rise over run, or change in y over change in x. For A to B, so our slope from A to B is going to be 2, a rise of 2, and a run of 3, so it'll be 2/3. Now for our slope from P to R, it has a rise of 4 and a run of 6, so it'd be 4/6. Oh, no, sorry, not AB, this is PR, is 4/6. And of course, 4/6 is exactly the same as 2/3. So they do, in fact, have the same slope. So a quick explanation there, we could just write down that AB and PQ have equal slopes, therefore they are parallel. All right, now there is one last thing we need to do to finish this question. We need to prove that AB is half the length of PR. And so we're going to be using the distance formula to figure that out. So let's start with the distance from A to B. We're using the distance formula, which is x2 minus x1 squared. In this case, that would be 1 minus -2 plus y2 minus y1 squared, which would be 5 minus 3 squared. That becomes the square root of 9 plus 4, so root 13, if we're not rounding it. And so I'm just going to write AB there, so we'll remember. Kind of running out of space, I'm just going to zoom in here. Okay, so now we're going to find out the slope of, not the slope, but the distance of PR. So for that, we'll take the square root of 3 minus -3 squared plus 3 minus -1 squared. And that's going to become, let's see, 6 squared, so 36 plus 4 squared, 16. That becomes root 52. Now, 4 is a perfect square that we can take out of this radical, right? And what I mean by that is 52 is the same thing as 4 times 13. And the square root of 4 is 2, so we pull that out of the radical, and it becomes 2 root 13. And so at this point, we have essentially proven that the length of AB is half of PR. We can see that the length of PR is 2 root 13, and AB is just root 13. So you could probably write something along the lines of this here, where AB equals half of PR. All right, so pretty lengthy and involved question. There was a lot going on there. I hope that was helpful, and that's all for this video. Thanks for visiting JD's Regents Preparation.